Great. Great, thanks. And I'll hand over to Ben. Thank you very much.
That's great. Thank you. It's quite funny seeing a picture of myself and Kathy on a nice sunny day in Paisley. That was a great visit from Carmen last week. Let me share screen. That's so I know what I've got. Here we go. Right. Well, it's a great privilege to be here. Thank you for the invitation and for trusting me with the story of our what we've done. And overall, I think some of this will be useful for some people, some won't be useful for others, and hopefully this can help each of you along on the journey. So that's the house, 1970s bungalow. How many thousands of these were built of some design or other in Scotland in the 70s? A lot. So essentially you go up in the middle of the house in a roof, in the stairs, and then you've got rooms at both ends and a dormer straight ahead. Ours is particularly large. Don't know quite why they built it so big, but 260 square meters. We needed the 5 bedrooms. We are a family of 5. We have often got guests. That's why we needed the larger house. But also there weren't many houses available in Paisley. We were quite surprised actually when we found the house to be so big when we actually set foot in it, having acquired it in 4 weeks flat. Another view here from the east on a rare day of snow. Here you can see where the differential melting, let's see, I have science in me talking differential, sorry, but the areas which melt first obviously have heat from below, and there's a line here, for example, which is getting a bit of warmth from the room and roof non-insulated area at that point. So motivation, I was asked to share a little bit about motivation. It is really interesting how there's so many different motivations. Most of us do combine around a few, but there's a different mix and different people. Fundamentally, we've chosen careers that don't pay all that well, but we did have quite a lot of capital. So we thought what we have to do is reduce running costs as much as we can. And also to have more predictability in running costs. I think most of us were shocked, well, taken hard the extra cost during the years of the beginning of the Ukraine war. And those price swings really hit various people. Very heavily motivated to reduce carbon. Also, I didn't want to get us to a situation where suddenly one weekend the boiler packs up and guess what? You have to get a distress sale just to replace the boiler. I've seen that happen. I've supervised it years ago. You can do it. But then you've basically locked your heating in for the next 10-ish years at least. And yeah, so by planning, we wanted to get to avoid that. Other motivations. There is quite considerable air quality improvement. If everybody moved away from burning gas, then there would be fewer asthma cases. It's really clear about that. Number one, for us, there is a motivation within our faith to do things that look after the earth, or as the Pope calls it, our common home. Common not just with people around the world, but common actually with non-human creatures as well. I mean, it's a sort of a sacred duty, I think, to do what you can to reduce your negative impacts. Coming back to it, I am a climate scientist by training. My work involves quite a lot of communication on the science. I'm not in a university post now, but really, if you haven't noticed, we are in a bit of a pickle around climate. And the sooner we can reduce burning things, the better for everyone. And although you might think that your own contributions are small, you probably did vote, I hope, maybe you voted a couple of weeks ago. There's a general sense that a small contribution still does matter. You know, but it's small, but still important. And at the end of the day, all that burning is going to have to stop one way or another, really as soon as possible, certainly by 2050. So let me take you through the various steps we've taken, and then we'll go more deeply in. So insulation in lots of areas, a loft, cavity walls, underfloor, the dormer window cheeks, that's the sides of the dormer, so I'll show you that. And this the sloping roofs of the house, which is often referred to as room in roof. And where I came from, I lived for 20 years in London, we'd call it the eaves, but I know here generally people call it the coombs. That's the narrow bits around the bottom for you who are not in Scotland. Then an air source heat pump, which involves quite a bit of radiator changing and a new water tank. We've also put some solar PV. You probably saw it in that picture in the snow. Not a huge array, but something, and some batteries, which ended up being very, very useful. And we didn't realize how useful they were going to be for the cost aspect. And then I won't go into this in detail, but we did end up with a fairly elderly EV. It's 10 years old. It still has 80-something% of its original battery. I think it's 89% of its original battery. It's done 92,000 miles, including 10,000 for each of us in the last 2 years for us. That has, again, had an unexpected benefit to the total running costs. I'll try to fit that in, help you understand that later on. There's a little bit of a geek in me. I would have been an engineer, perhaps, if I hadn't been a climate scientist. And there's elements of energy monitoring and tariff optimization that has been important to reducing costs. Some of it anyone could do, some of it only people who are really interested will do. I get that, but it's there. So arriving in this house that kind of surprised us when we got the keys. Yes, it was an enormous boiler, because I've seen in the house, 33 kilowatts. That would run 2 showers continuously, I think. And 13 years old, it was still going strong. There was no reason particularly to replace it, but still 13 years it's quite a long time, isn't it? And most of the radiators were these kind of 1970s single panel radiators underneath windows. That's what we did in those days, isn't it? It's not the most efficient place to put a heat source because some of it goes straight through the wall. Although in certain areas where the couple had obviously lived the most, they had doubled the radiators with new ones. Then up in the loft, lots of insulation, very badly laid out, with, incidentally, a certificate from the installer saying this is, to government standards, 300 mil. Yeah, 300 mil, but all over the place. I mean, look at this, lined up along the rafters, so that there was a huge heat loss between each one. I then spent a couple of days actually with a mask on, rearranging those to go across the ceiling joists, and that immediately improved our how much heat we were losing from the upstairs rooms. It really helped. Then try and picture where we are here. You can stand up in this coombe here. To the right is one of the rooms in roof. To the left, you've just got roof, that's rafters with nothing between that and the outside world apart from the roofing felt and the tiles. So basically no insulation. They had, probably originally in the 70s, but this very, very thin bit of insulation. You can see my cursor here on the right-hand side. It was about 10 mil thick. It was very, very itchy old stuff. Must have made some difference. There was no insulation along the ground there. So the room beneath was losing heat into this unheated space. Yeah, not great. On top of that, then I got to the very corner where the roof comes down and joins the rooms beneath, and you could look between the brick and the outer leaf of the wall. Can you see that where the red lines are is kind of the wall going across here? In some places you could see cavity wall filling fine. In other places you could stick your hand a long way down before you met any cavity wall. Under the floor, the ground floor, quite a significant space. You can crawl around there all right, but no insulation. What you can see there is the floorboards. So a few steps then, I'll take you through the steps straight away. Underfloor insulation. It's just simple mineral wool held up by staples. I got this company, Glasgow Underfloor Installations. I did it in half a day, which for such a large area, I couldn't believe it. Looked into grants for people who quoted, who would have been able to get the grant from, actually were going to be more expensive in the end. So Glasgow Underfloor Installation have my vote. After quite a long process with the insurance-backed guarantee people, they came and filled the gaps in the cavity walls. So we now have fairly much continuous cavity wall insulation. That's helped. And let's try to take you through the room and roof situation. So that red line I've kind of sketched on there is that was ceiling above what's actually the kitchen. That was not insulated. That was the vertical wall, similar to what I showed you in a picture just now. That was insulated with this tiny bit of mineral wool. That sloping ceiling there had no insulation at all, just plasterboard, then rafters. That was loft insulated, which, as I said, was badly done, but is now done well. That's one of the easiest jobs. Then another slope, then another badly insulated vertical, and then, then another insulated, uninsulated flat area. So this is your room in the middle of a roof, and getting that to be well insulated clearly is important, because that's an awful lot of surfaces through which you're losing a lot of heat. And with respect to my octogenarian father, came to help. Maybe that's where I got the DIY bug from. We are here dismantling a built-in wardrobe to expose this plasterboard on the slope. And again, behind that in some places there was a little bit of mineral wool. Most places didn't, and we then removed that. So again, talking us through this, you start with plasterboard, then there's the rafters with gap, then you've got sarking boards, roofing felt, and tiles. So this is really not good for heat retention. Having said that, as soon as we removed the plasterboard, we did notice we lost more heat more rapidly. So it was doing something, but huge scope for improvement. So first thing we did then in this area was to employ a company to fit room and roof insulation, and they fitted between the rafters, they fitted this PIR, that's let me see if I can get this right, polyisocyanate. It's the yellow foam you see on building sites with silver foil either side. And they cut and fit to fit here and to fit into the next bit down. And they correctly left a ventilation gap behind so that the sarking boards could be ventilated. You need to do that. They didn't always do that, by the way. There were some which they pushed too far and they couldn't get them back. It's very easy if you DIY, you just put a screw to stop it from going any further. And you're fine when you push it up against a screw, it won't go any further. So, when they did that, every day they did that, things improved. It was actually a very cold week. It was December 22. But quite quickly, I realized they hadn't done a great job. This is 1 or 2 centimeters wide, this gap. And you could feel the air coming through that. And considering we spent quite a large sum of money on that, and there's been a grant involved and so on, that felt a bit bad news. We did complain. They improved on it a bit, but not fully. And in the weeks that followed, some of these boards literally fell out. I had to refit them. Others, when they came out, you realized it was a very trapezoidal section they cut, so it wasn't the full thickness right away across. Yeah, all right, but not brilliant. And I'm not going to recommend that company. At the same time, they're not quite so bad, but I'm going to warn you not to go with them. You can ask me if you really want to. I'll tell you. And so one option then was we tried to spray foam in the gaps. It's a long fiddly job, but it does actually block it fairly well. You have to wear a hat, by the way, because if it's above your head, then something's going to fall out on top of you. And that is horrible in your hair, even the amount of hair I've got. Later on, this is this year, in a similar process, but a different part of a house, my friend and I were fitting a different product to the sides of the board. So this is correctly cut to width to get between rafters. And we have this product called Gapo tape, which is a sort of slightly squidgy foam taped with a self-adhesive tape that goes on both sides of it. And you can see it kind of wrapped round. And then you can put that in between your rafters up against the screws you put there first, so it won't go all the way. And it fills the gap quite well. And you'll find that if the joist, the rafter changes shape, which it probably will over time, this will move just enough, hopefully, to cope with that. If you look up Gapo tape on YouTube, very, very good instructions by a guy called Robin Clevet. And when I watched that, I thought, oh, that's what we needed to do. It is, of course, expensive, but the time saved is surely worth it. So then over that, we are then putting boards. So here's an example of a friend who came to help one weekend, where we've put a whole board across the rafters and we're screwing through into them. This one was a 75mm thick Kingspan Cool Therm, which is it's called phenolic insulation. So it's actually pink rather than yellow, and it has a slightly better heat resistance. And you're trying here to put the screw all the way through to hit the rafter. It has to go to the rafter, otherwise you've got no strength to it. And can you see here, there's a little, here, if you see my cursor, the screw has got a significant washer. It's about that size to spread the load. Just search for insulation washers, you will find them. It does, of course, cover the thermal bridges. Those rafters have got much less heat resistance than the insulation around them. So it's blocking, it's improving on thermal bridging. We actually put 2 layers on and offset the joins, so much less air could get through. At this point, it doesn't take much more effort to add more insulation. So it seemed just sensible. Let's put 2 layers on. That's him trying to find the rafter. You get better at it. By this stage, the warmth in the room is really tangible. That room was already feeling much, much, much better, especially overnight. It's actually a different room, this, but the next stage then was to put battens across. Again, these are screwed with long screws all the way through the insulation to the rafters. So because they're going to now carry the weight of plasterboard. This is our plant room, by the way. This is the tank and so on for the heat pump, which we'll talk about in a minute, and eventually gets enclosed in a wardrobe. Next stage, we're doing slightly belt and braces here, but there's a fear that your warm, moist air from your room, where you're breathing out warm, moist air or drying clothes or whatever you're doing, if it gets through to the cold rafters, could condense there and cause them to rot. It happens, not often, but it does happen. The way to prevent that ultimately is to put in a membrane. This is not literally a plastic bag. It's a membrane. It's more like Gore-Tex, I suppose. It allows a little bit of moisture through, but not much. It's relatively expensive. Takes a bit of time to fit. But yeah, knowing that this was going to last, hopefully, the rest of the life of the building, we thought we should do this. And then finally, Guy, my friend who's very good at fitting plasterboards, came and we paid him to do so. So a few lessons learned. Well, it really does work. You really do immediately feel warmer, and hopefully you're only doing it once. So let's say this house has got another 50 years left. It'd be great, wouldn't it? But every single year you are saving energy. So the method I've just described, it's only one method. There are others. Similarly, we chose certain materials, perhaps because I had some experience of those in a previous life down south. But actually, the more I learn about it, the more I understand that these are pretty bad for the environment in their process. Every time you cut them, you're producing lots of microplastics. It's not great. I could probably have experimented with wood fiber or even a multi-foil combination, something like that. So don't go, but this is the only way. Yeah, certainly Gapo tape, like I explained, is better than spray foam. You use less spray foam. In my enthusiasm, I removed the plasterboard from 4 rooms at the same time. Or was it 5 rooms? Yeah, it committed us to doing it, but really is a better idea to do 1 room at a time. It wasn't ideal for everybody. And really, the more you do it, the more you realize that there's a lot of attention to detail that's going to make the difference here between where the moisture goes, between where the air gets through and all that sort of thing. And that's the problem with trades. And it's one of the wonderful things about Loco Home and probably other setups like them, that you've got people who can recommend installers who can say, well, these guys are good, these are taking the time to do it well. That said, the total time seemed a lot. And I don't know if I would be prepared to pay somebody whatever the day rate is for what we ended up doing. So I don't see this as an easy solution to do. There may be improvements in techniques and materials coming down the line, but there you are. Right, one other area of insulation to talk through is the dormer, the cheeks of a dormer. So if you can imagine, this red line is kind of where the roof beyond that dormer is coming down. So you don't have to insulate the whole wall because most of it's just against the next bedroom. So we fitted it as a kind of triangle and then framed it. Same on here. There's a bit of a ventilation gap behind that so that any air or damp that gets in from outside will be able to hopefully dissipate. And then the funny thing, that under a dormer, you've always got this tiny triangle of roof area, and the people we paid to do the installation right at the beginning tried to crawl down there and fit wool in the gaps. Yeah, we eventually said, let's rip the plasterboard off and just do what we did there, which is fitting insulation between rafters and then overboarding, and then at this stage we're now fitting membrane. That's me and a nephew. But look at that. In the end, it's been a great room for the last year and a bit. for my 15-year-old. Our 15-year-old. I just came across this picture, made me laugh. That is not even half the cans we have used of spray foam. I was trying to find a way to recycle them. I didn't. But, you know, materials, yeah, you use quite a lot of materials. So I could say more. Perhaps the place for that would be the local home forum to get into details of the different processes. If you ask questions at the end of further details, like, for example, what we do right at the bottom of the slope where it's really fiddly to make it airtight. Anyway, you're welcome to ask questions at that point. But now I'm going to go on to the heat pump journey. Let's just tell you where we're going. Starting point, obviously. What we needed to know. I'd never lived in a house with a heat pump. And then the process of finding a good company and getting the quotes. The actual process of installation, what it was like. And then we'll go through the costs in some detail. And then in more detail, we'll look at the running costs. Actually, we found an incredibly cheap way to run this house. And the carbon reduction, which is market. So having moved into the house, you then register with the energy provider. Our previous energy provider was this company, E.ON, who I do not recommend because they held on to our cash for a very long time after we left them. But they're not monstrous. Walked in and they were expecting the annual cost to be over £6,000. And if we look specifically at the gas, the estimated cost of £4,000. Now, this was the time when gas prices were shockingly high, and they're still fairly high. But the idea of spending that much money when we have a certain amount of capital and not a huge income, we knew we were now on a mission to try and stop that. But that's kind of, yeah, I'll explain why that's important in a minute. So based on the previous owner's usage, the gas is 4,500, yeah. But that was an oldish couple. I think they probably lived in just 2 or 3 rooms. We're a family of 5. For a start, that means more hot water. And like I said, the costs were peaking. When things started getting cold in November and December, we found £10 worth of gas per day, including hot water, was still only giving us a pretty cold house. That's before any insulation, apart from the loft rearrangement, had happened. Then over Christmas, by now we had a few bits of insulation in. We had a whole load of our family staying. And so for 5 days, we put the heating up to at least 18, I think 18, 19, and it could heat the house for 18, 19. But the gas cost was for £250. So you're not going to carry on doing that through the rest of winter. That's at least the 4,000 that the previous owners had been paying or would have been paying. Anyway, just to say, I can't really give you a before and after because we weren't going to go through one winter just as an experiment and lose £4,000. That went towards the improvements, and we actually froze. We had sleeping bags in our beds and tried to keep it as cheap as we could bear. Hats off to my family for coping with that. We all agreed on it, but hats off anyway. So an initial exploration. Now, this was a very, very important point. Was some friends, actually in a church I was in at the time, have a big old stone house, and they had shifted to a heat pump. So great, they had me around for a cup of tea, me and a friend, and we looked around. It was not a well-insulated house. It's got big glass areas and so on. But their heat pump was happily heating the place relatively cheaply. And I thought, right, if a house like that can cope with it, with the solid walls and so on, okay, we are probably in contention here. And then I had an initial discussion with a local installer here who took one look at the particulars of the house and said, well, we know what that sort of house is going to lose. You'll need at least a 16 kilowatt heat pump. So remember that 16. And then another installer said, yeah, we'll design it, but you have to get the heat pump survey done, which actually is quite sensible, I think. By the way, Local Home Report does a heat loss survey. So then you've got an independent survey. And this is the key thing. What level of heat will your house actually lose? You can calculate it, and you can also look based on your heating records. And then the guys from that house visit had recommended a particular installer, Renewable Heat. And as I got onto Twitter and so on, I found out they really did know what they were talking about. And these are the people actually who did everything right. And interestingly, I keep bumping into people who have good heat pump installs, and they often have the same installer. They're not the only good installer in central belt of Scotland. On the Local Homes Forum, we find there are several other good installers, but people are getting good results from. But I would earnestly recommend these. And I think the difference between a good installer and an average or poor installer is just enormous. It's probably an order of magnitude or something like that. It's just an enormous difference. It's not the same as if you know how to fit gas boilers. The whole system is substantially different in terms of the baselines you're starting with. And we'll explain a bit more as to why in a minute. It's not like a new universe. It's just there's enough difference, but people have to know that difference. And what's our aim here? Our aim, your aim, if you're thinking about a heat pump, is to avoid a disastrous installation, the one that gets into the Daily Mail or whatever, where you're paying 4 times as much and your house isn't even warm. It's clear such things happen. What a ridiculous situation. What a shame. Expensive and unable to heat. And so reading around, trying to find out what I could, basically I just watched various YouTubes, and I'll just go through these quickly for you. At that stage, I didn't even know Local Home existed. Maybe in your area, if you're not in this area, there would be something similar, but certainly my first step would have been to join up and to have got a survey, an independent survey, because then I'm not relying on the different views of different tradespeople. So my first recommendation, please everybody, look up HeatGeek and watch their consumer advice. You don't have to be all that technical to understand it. You don't need national 5 level physics. You need some awareness of how heat moves, but you can work it out from them. This guy, very brilliant at installing very efficient systems in all sorts of homes. So just look him up, look up his different examples of homes. This one's a Victorian house, obviously not a simple one. Those are solid wall properties in the London area. So the answer was it is possible, and his is actually a very efficient system. If you want to get even more techie, we've had Paul, I think, from Local Homes on this particular podcast talking about his journey of the heat pumps. So that's another one for better talk. Now, how do we get a process? What was the process to get a quote? Well, to try to move things along rapidly, we supplied things like floor plans, so the sizes of the windows, how old the windows were for single, double glaze, that sort of thing, radiator sizes, where the insulation levels and so on were. They would have visited, but it would have delayed everything a bit longer, and we were freezing. So based on that information, they did this design, and that gave us an idea of what we'd be looking at financially. They did the heat loss calculations based on those informations. They did this design of which rooms would need what size of radiator, what kind of heat pump we'd need, and they suggested that we'd need a 12 kilowatt. Do you remember the rule of thumb person for this kind of house said a 16 kilowatt? They said at 12, they'd calculated 10.8 kilowatts heat lost at minus 4.6. So this is the way people talk about this, that if the temperature was minus 4.6, your house would be losing 10.8 kilowatts all the time. Think of 10 bar fires, keeping that heat at a standard temperature. That's the inefficient way to do it. Instead, the heat pump should be able to provide at least that much to make it work. We then had a visit from one of the renewable heat guys. They had a good look at it and worked out where you might site the heat pump, where you might site the hot water. They also, because they could see we'd ripped up out several rooms upstairs, they knew that we were very serious about the heat loss. So they could do about the insulation improvements, and so they could revise the heat loss downwards. And we ended up then with a design for a 10 kilowatt heat pump unit based on a heat loss of 7.94, so around about 8 kilowatts at that same temperature. Their hands are slightly tied. They have to design according to MCS, which is a sort of a trade standard. So they couldn't, I would have liked it if they could install an even smaller heat pump, because I thought our insulation levels were going to be at the nth degree. They weren't probably going to be able to do that. It has to be designed to keep an average family happy at sort of 21, 22 degrees. So the next bit of a process was to pay for materials. You've got to pay up front for these things, and that's not it's not great, really. We submitted the Home Energy Scotland application at that point, which eventually covered 7,500 as a grant and 2,500 as a long-term loan. So that brings the cost down. We can talk about that in a second. Design. So the whole point of a heat pump is you've got to get low temperature water going around your house. The lower the temperature, the higher the efficiency. Now, heat pumps can be designed to do what a gas boiler does and sends sort of 60 degrees water, or 50 degrees anyway, around your house. That's possible, but that's a very inefficient way of using the amazing technology of a heat pump. The larger the radiator, the lower the flow temperature, because you can lose that heat into your rooms. If you had an underfloor, again, but you need close spacing of your heat pump, your pipes. So in the end, all the single radiators were replaced with doubles. And in fact, we would have changed a lot of those anyway, because they were in inappropriate locations on the window. So with renovations, we probably would have moved a good number of those. Later on our list, how many were changed and how many were kept. They replaced most of the pipework, just because the locations were different. Most installers like having nice, clean pipework, but it's not going to bung up their new machine as well. But anyway, that is what happened. They had access under the floor. It wasn't too difficult for them. And we ended up with this quite large hot water tank, 300 litres. I thought that was a lot. So just so you know what a double convector is, you can see the fins through here, which allow the heat to go up through there. And those are the old ones. Actually, those did have some fins on the back, but you can see those are typical 1970s kind of radiators. And here they are in the background here. Renewable Heat are fitting the heat pump just outside here, and with the various pipes coming down and so on. Bump in the road. We discovered that we would have to upgrade the we have to firstly get the connection, the electrical connection to where the heat pump would be sited. And it's quite a thick cable. It's a 6mm cable. Think the kind of cable that supplies an electric shower. It's not a simple thing to fit through a house. So ended up that we put bits for bullet. Is that right? We had a complete changeover of the consumer units, so that then we could also have a bit of future proofing with the solar and then the EV charger, that sort of thing. So that's what we have now. As it turned out, it was a relative that helps do that as a qualified electrician. So we didn't actually pay £12,000, but it would have been something like that to do. Just to note here, that of course, can you see the meter is a smart meter. And for what I'm going to talk about later, having a smart meter is important. So, the installation process. Getting it up our drive was a scary moment. I thought this is just going to run downhill and kill somebody's car or something. But there we are. Strong guys pushing it up the hill, and overall it took 2 weeks to install the radiators and the heat pumps. So it's not a small job. Some rooms had disruption, some had basically no disruption because they could work from underneath. The biggest disruption was where we were putting a tank, and we'd already ripped the plasterboard down to put insulation. So it was disruptive, but not much more so, considering we just moved house and we're renovating a few bits. Radiators. We moved and replaced 7 of them. 2 rooms didn't even have radiators, so we added radiators. And then 5, which were already these double convectors, we left untouched. So you don't need to replace every radiator. It has to be assessed by room. And that's what the tank looks like. Just to get your eye in, if you're interested in these things, there's 2 expansion vessels, one for the hot water, one for the radiator circuit. Some designers seem to put in all sorts of extra things called low loss headers and buffer and volumizers and so on. It seems from my general reading, I'm not quite an expert of course on this, but it seems from general reading that the more complicated it is, the badder design it is, the worse of the design is. So something to look out for. It works efficiently if you leave the radiators open and you hardly use the TRVs, the valves at all. You just leave the radiators to flow all in every single room. It might seem very different to how you've run your house, where you might have had some warm rooms and some rooms you kept cold, but it still ends up more efficient. It's extraordinary. The efficiency comes with having the low temperature for a long time, and that will counterbalance the sense of having a cold room which you don't really need to heat or something like that. So our earliest experiences, having got it, so just in the week before, we spent £10 per day on the gas. I think that was set at 11 degrees. Not much fun. We used to go to IKEA for a warm meal, you know. Yeah, not ideal. And we had some insulation by this stage, but some parts were not yet insulated. Again, I can't give you an exact before and after comparison. You see this as a journey. And it was finally commissioned, I think it was the 7th or the 8th of March. And when we had a really cold week, that second week of March. So it was good to see with sub-zero temperatures, the heat pump was perfectly capable of keeping our house warm. And we started off at 16 degrees because I was nervous, this might still cost us, you know, £100 or whatever, but it didn't. It kept us cold, and we could immediately kept us warm, and we could immediately see that it was relatively cheap to run. And again, like I said before, low and slow, so long run times at low temperatures. It's actually really funny to touch a radiator. It's colder than your human body. It might be 35 degrees, but it's able still to heat the house. It's just different. Just to talk briefly about the hot water system, most of us would have been used to having hot water on demand. A combi boiler, it's great, convenient. What I've discovered is that one tank of hot water is roughly one full bath. And I tell you, my teenagers sometimes run a whole bath. So you then can't have a shower in the next 40 minutes while the hot water reheats. Okay, so just be aware there are these kind of behavioral changes. You know, some people older than me might say, but we always lived that way. Yeah, but we've got used to having a combi boiler. And I would say we started to play around with some of the settings to get it to run more efficiently. And the forums are your help. And to some extent, the installer was helpful as well. But still, that's only a few percentage improvements, actually. Maybe we've improved it by 10%, something like that. But it's worth it, but it needs a bit of getting used to. It's nice if you have a community of people to ask. So the money side of things. Yeah, we got that grant, just mentioned that. So what did it cost? So the first steps of decommissioning and putting the heat pump in is about 13,000, and then the radiators was almost 6,000 again. So you could say some of those radiators would have changed anyway as we improved the house, but overall, to the installer, we paid just under £9,000. We'd also put the electrical works in, which would have cost us something like that. So basically £20,000. Well, that's a lot of money. That's a lot of money. And let's not forget, thank you everybody who pays tax. Yes, it did cost the taxpayer £7,500 and helpful. A few moments of joy before I go on to the way the costs have worked out. There's a moment when we remove the gas meter, which Octopus Energy, by the way, do for free. Other people seem to charge. And I just thought, wow, this is fantastic. We've literally got to a stage where this house is unlikely to ever be burning a fossil fuel again. It's fantastic. And we no longer pay a standing charge. But it was a great few weeks as we discovered that, yes, it actually worked well. It did actually heat the thing. And seeing various people who'd be skeptical, I mean, it's sensible to be skeptical of new things, I'm sure. But seeing their reaction, oh, this house is nice and warm. It's a great feeling. There's a few moments, though, of awe, which I'm coming to now in the talk. The running costs, yeah, wow. And the total CO2 costs, so it changed. Quite extraordinary. I'm going to talk you through how I know what the running cost is. I've got a PhD in climate change, so I'm quite careful about data. And last night I ran the figures all over again from a slightly different 12-month period to check I wasn't deceiving you in any way. Because I'm going to make some bold claims in a minute. So they need bold, extraordinary claims need extraordinary evidence. I didn't just get the usage data from the Valent heat pump, but also from this special device which had been installed at our consumer unit. And that just measures the amount of energy going into the heat pump overall. It does it by hour-long segments, so you can do different times of day, and they agreed. So I'm going to take this period here from April 2023 to 12 months later, and we use just over 3 megawatt hours. I'm going to talk us through here how I've done this, and we'll try and do it in just one table. We'll add a few more lines as we go. So if you remember, the first line here is what E.ON thought we would be likely to use. They expected us to use 27,000 kilowatt hours of gas for both the heating and the hot water, and that would cost us about £4,500 nearly. But that wasn't comparable with what we've done, partly because we're probably running it a bit cooler as a house, and partly because we've started to insulate. So the next line I've back calculated from what the heat pump actually gave to the house. So I'll come back to this line here in a second. Let's go to the third line, electricity actually used by the heat pump. So we know that it's 3,190 kilowatt hours of electrical energy, but it's given us into the house, it's given us 12,000 kilowatt hours of heat. That's the magic of heat pumps. It's borrowed some heat from outside. It's combined it with the outside heat, with the heat used in the pump to give us a lot of energy in. So that's how much heat would have been needed to be supplied by the gas boiler. It's not quite fully efficient, so we need a bit more than that. And that's how I've got the estimate for how much the gas would have cost for that same year period. Okay, would have been about just over £2,000, something like that. In practice, with a normal tariff at that time, it's not what we paid, but a normal tariff of electricity, 28 pence, would have been just under £900. So already we're saving money. And that is because the heat pump scavenges this extra heat from the air outside and adds it to the effort it needs in its pumping. So that's the reference case. Okay, I'm not using what Eon said at the beginning because we wouldn't have used that much gas. I'm going past that. Right, so now I've got to introduce you overnight electricity. Most of you are probably familiar with something like Economy 7. Some will be familiar with this sort of tariff, which is Octopus Intelligent. And the purple line there is the cost through the day, this particular day, 3rd of May. So we've got cheap electricity overnight, then it's expensive during the day. Okay, so we've used very, very little during the peak time and quite a lot overnight. Overnight is 7.5 pence. So we've got this particular tariff because we have an EV. It's an EV charging tariff. It's an electric car charging tariff and a particular charger as well. We wouldn't have got such cheap overnight if we didn't have that. There are other tariffs, but they're not quite as cheap. So because I've got the data from the Shelley, which is split into hours, we're able to see how much of the heat pump was run on overnight timings, which is about a third of it. And that would have cost us £91. And then during the daytime, if we'd been paying for it at that price, the daytime would have been about just under £600. Okay, so the total cost just under £700. That's just by having an overnight tariff. That's already quite significantly cheaper than the reference case. But that's not actually what we paid. At this point, I'm going to ask you to, as a bit of fun, throw it into the chat. With 5 minutes to go, put into the chat what you imagine maybe the cost would have been that we actually have paid. Have a bit of fun with that. Well, I'm coming to it in a minute. So that's a 70% reduction in cost compared to the equivalent use of gas. So I've got to introduce the other green tech then, which is the heat pump, the solar PV with its inverter and its batteries. And the batteries were the key thing here. It's hard to know how much the solar helped. It did help, but you don't get much solar in the winter. You really don't. So this battery cost us £8,000. We've had to add bird proofing to it as well. By the way, please avoid grow watt if you're going to get an installation with a solar. They're relatively cheap, they're technically capable, but you can't control them very easily because they keep going offline for hours and hours and hours at a time. So just avoid them. There are better options out there. So the secret sauce then for low running costs, time of use or a smart tariff, is that the EV tariff sometimes gives you cheap periods during the day as well. This doesn't apply for everyone, but I'm just telling you this bit of our story, I suppose. And so if we look at this day here, that was the 7th of March, because you see that there were several points during the day when the pink line drops and we get cheap periods. At that point, we whack on the batteries, the home batteries, they charge up as quickly as possible. We put the heat pump maybe up by ½ a degree, so it definitely is operating. And we use as much as we can for about an hour-long period, or in this case, I think it was an hour-and-a-half period. Then it stops and we have to reset it. At the moment, by the way, I'm doing this manually. But I'm going to get into the automations in the next month or so with something called Home Assistant, which will detect when the cheap periods come. And just to help you picture then what this means, it means during this particular month, which was February to March, our average cost of all our imported LNG, was under 8 pence per kilowatt hour. So the battery is bridging the times when you don't have the, you see, you've got these periods of cheap during the day. In between, the battery is taking the load. You can load the battery back up again. So here we go then. This particular scenario, as I said, perhaps wouldn't work for everybody, but could work for more people than we might think. You either need to have a large battery or these extra cheap periods during the day. Remember, we've got our total usage, we've had our overnight cheap tariff, and then the calculation of what the daytime cost would have been if we were paying for it off the grid, but actually we didn't. We used battery stored and low-priced periods during the day. So we'll say that's 8.2 pence because the battery has a slight load from the cycle. And that's an incredible figure. We're saying that instead of being 590 for our daytime usage, it's actually 161. So we add the 161 to 91. Total paid. Total paid. It's £253. Quite extra. I mean, when I did the calculations on this 2 months ago, I knew it had been cheap. I didn't know it would be that cheap. In fact, last night I had a sudden scare, but maybe I'm deceiving everybody. It's not true. So I took a different 12-month period, did the maths a different way, came up with very, very close to exactly the same, to the same figure as that. It's true. It really has cost us that little. We pay £50 a month to Octopus Energy. So that then is giving you a reduction in cost of 90% compared to this reference case of the gas. Very, very satisfying if you look at the carbon. Whereas the previous owners perhaps would have been emitting 5 tons, and if we'd been using gas for our current arrangements, we might be emitting 3.2 tons. We're emitting less than half a ton based on the grid intensity. And actually, I would argue that Southern Scotland has a lower grid intensity than that. So it's really satisfying. Right, just wrapping up now then, let's do an overview of all the different measures. Which ones are useful. This has got some shocking costs at the bottom. And when you realize that we've actually spent tens of thousands, yeah, it's a lot of money. We're hoping, well, we'll talk about payback in a second. So I'll take you through the table using the example at the bottom, which is the heat pump, the air source heat pump with renewable heat, installed in March 33. The total cost was just under 19,000. Some of it was a grant, some was a interest-free loan. So the immediate cost to us was 8,700. But by the time we paid off the loan as well, we will have paid 11,000. Okay, or 11 and a bit thousand. Do you see how that works? And then I put towards the end, I put a star system. Well, the heat pump has 5 stars. There's no question to me that heat pump installer, that particular installation, is being brilliant. It did need to be combined with the EV tariff to make it that good. There are other tariffs that should also help, but perhaps not be quite as generous as that one. The electrical works also 5 stars. The home battery, 5 stars. I hesitated to install the home battery. I thought, oh, we'll wait a bit. They must be coming down in price. I'm very glad we did. We might install another one to increase the capacity. Solar, yeah, solar's great, but we haven't saved a huge amount of money on it. It's going to take quite a while to repay. Room and roof, yeah, great, but it's been an awful lot of work. So I've given it 4 stars. Between the rafters, room and roof, as paid for, and costing, 7,000 quid, probably not worth it. I think we should have done it ourselves. There were some places perhaps we didn't need to fill between the rafters. We could have just gone overboarding, but really quicker. And the underfloor installation, 5 stars, no question. That gets the full approval. But it is true that the total investment here by us and the taxpayer has been £54,000. Well, having moved house, some people would fit a new bathroom or a new kitchen. That might well add up to what we've actually paid out so far, which is 30,000. Yeah, okay, I take it. This is a lot of money. Is it worth it? It's really hard to know. Do you know that it is really hard to calculate payback times because everything changes all the time. The costs change, the cost of energy changes. But I think we're looking at about 9 to 11 years. And the nice thing is those 9 to 11 years, instead of burning gas, we are using essentially wind energy for most of it. So heat pumps are not all that disruptive, but they are somewhat disruptive. It's helpful if you could be doing other renovations at the same time. We've still got some flappy bits of wallpaper, but are going to have to be matched whether the new radiators are slightly smaller, that sort of thing. Having the capital available obviously is a limit for most people. I understand that. And actually, we had to pay out first and then get the money back from Home Energy Scotland. Not easy for many people. I wish there was a way to do that better. I don't have any suggestions of how, but that is a challenge. Thanks to 1 or 2 people who actually lent us money for a month. We would say you don't need the ultimate insulation to have a heat pump. You really don't, but any installation helps. So we could have installed a 16 kilowatt heat pump, and looking at the actual running costs, we would have been saving money compared to the gas. But we're glad that we have done the installation. And then this is funny thing, but the different areas of green tech help each other to save you money. So the batteries help, the EV charger helped, and we never knew that was going to happen with our ancient car. And then the carbon savings, yeah, really significant. It's about 90%, just extraordinary. All this would have been easier if we'd known of local homes earlier on and done an assessment. Now, I obviously knew quite a lot about this from previous existence and DIY experience, but still, to be able to prioritize things from an independent perspective would have definitely